Next presenter is Mr. Dr. Hyung-rae Kim. He is Chief Engineer of Hyundai Engineering and Constructions, and he's responsible for team leader of tall building team. He's an innovative engineer in the field of building material and construction. He got a PhD in Tokyo University of Japan in 2008. Originally, his major is the evaluation on the deterioration of load-bearing capacity in the reinforced concrete structures with a corroded the rebar. Okay? His presentation is for evaluation of concrete pumping performance for high-speed construction of high-rise building.
Good afternoon, ladies and gentlemen. My name is Hyung-rae Kim. I'm team leader of tall building team, currently working at the Hyundai Engineering and Construction R&D Center. Today, I will make my presentation on our research project, evaluation of concrete pumping performance for high-speed construction of high-rise building. And the subtitle of this research is Evaluation on the Characteristics of Concrete Fluidity and Friction Resistance inside pipe using the friction resistance testing system. Contents of my presentation is as follows. First, background and purpose. Second, friction resistance and flow of concrete in pipe. Next, outline of experiment and results of experiment. Finally, conclusions. At first, background and purpose of our research. To succeed on high-rise building construction, high-strength materials and high-speed construction, especially concrete is the most important element. Therefore, many studies about the high-strength concrete and its pumping technology have been conducted. Most existing studies today are limited to developing ultra-high pressure pump, high-flow concrete, and pumping trial tests. But actual concrete pumpability is changed under the various conditions. Existing test methods to measure slump and slump flow of fresh concrete are not sufficient to evaluate the pumpability of high fluid and high strength concrete. Therefore, method based on rheology is increasing used for quantitative and reasonable evaluation of concrete fluidity. So, it is necessary to establish economic evaluation and prediction method to optimize pumping condition for high-speed construction. And it is essential to use the rheology approach to evaluate and predict pumpability in regard to fluidity, viscosity, friction resistance, and segregation of concrete. For this research, method of measuring the pumping pressure and inner surface friction resistance was developed for pumping evaluation system. And the relation between inner surface friction resistance and pumping pressure with the series of concrete mix proportion was investigated. In this chapter, I will briefly introduce the basic principle of friction resistance and flow of concrete inside pipe. Well, what are the characteristics of fresh concrete flow in pipe? Concrete is liquefied solid with yield stress and plastic viscosity. unlike ordinary sticky liquid, the concrete flow in pipe is very complicated. Because of its characteristics, the loss of inner pressure with the distance from pump is caused by the plastic viscosity of the concrete and the inner surface friction of pipe. Especially, the inner friction resistance inside pipe is the most significant element for evaluating the pumpability of concrete. Concrete flows inside the pipe by plug flow and slip flow. But when plastic viscosity of concrete is high and inner pressure is high, a shear flow is occurred due to the inner friction resistance. This shear flow is called as Bingham flow. Bingham fluid amount, including the plug flow, is influenced by plastic viscosity and pressure loss in pipe. As you can see, this is pressure loss in pipe, and this is plastic viscosity. And total fluid amount in pipe is sum of Bingham fluid and slip flow. In this regard, Architectural Institute of Japan proposed the equation between slip velocity of concrete and friction resistance in order to calculate the pumping pressure loss. And from these equations, the pumping pressure loss is predictable. The next is outline of experimental plan. First, experimental factors and levels. To find the influence of concrete fluidity on pumping pressure, compressive strength and slump flow were set as factors for concrete mix condition, and pumping speed and repeated pumping elapsed time was set as factors for pumping condition. 4 levels of compressive strength, 40, 60, 80, and 100 megapascal were applied. Concrete mix proportion is as follows. Total 9 series of concrete mix designs were classified based on target strength. In the series of mix, the first number, 20, means a maximum size of aggregate. And the next number, 40 to 100, means compressive strength. And the last number means slump or slump flow. And this F means fiber reinforced concrete. Next, test methods for rheology. The Bluefield Company's DV3 rheometer was used in the rheology test. Shear stress and shear strain rate was calculated by torque of spindle, which was measured by gradually increasing the spindle rotational speed in a sequence of 50, 100, 200, and 250 RPM, and then decreasing. The mortar used in the test was taken from the concrete before and after pumping by extracting coarse aggregate by sieving. Next, test methods for pumping trial. Pumping performance evaluation system, as shown in this figure, was developed to measure pumping pressure in pipeline and inner surface friction resistance. And using this system, pumping characteristics with mixed condition and pumping condition of concrete were investigated. The length of pipeline was about 50 meters. This is pumping evaluation system, and this part is testing pipe. Next, test methods for inner friction resistance. This figure shows test equipment for evaluating the inner friction resistance with the pumping condition. The test pipe can move freely due to the two slip joint. When concrete is passing through the test pipe, force acting at the test pipe was measured by load cell installed outside. These two end slip joint, and here load cell. And when concrete is passing through this pipe can move freely in this longitudinal direction. From the first F, this F, inner friction resistance stress can be calculated as shown in this equation. The next is results of experiment. First, rheology property of mortar. The upper figure shows the test results of plastic viscosity and yield stress of mortar according to concrete mix conditions. Generally, the higher strength of concrete shows higher rate of plastic viscosity and yield stress. And at the bottom of the pictures, the result of measuring rheology before and after pumping shows general tendency of decrease in yield stress and plastic viscosity after pumping. In the pumping, with same concrete mix, the pressure in pipe tended to be bigger within the increase of pumping speed. And pressure and friction resistance under the repeated continuous pumping showed a tendency to decrease with time. In this graph, x-axis is elapsed time, and y-axis is pressure in pipe and frictional resistance, respectively. This part is pressure in pipe, and this y-axis is friction resistance. This figure shows the relation between pumping speed and pumping pressure. In this graph, x-axis is discharge rate of concrete as pumping speed, and y-axis is pumping pressure and friction resistance. Pumping pressure and friction resistance tended to increase with the increase of pumping speed. From this result, it is considered that the increase of friction resistance is related to pressure in pipe. Pressure loss in pipe tended to increase due to the increase of friction resistance with the increase of concrete strength under the same pumping speed. In this graph, x-axis is discharge rate as pumping speed, y-axis is pressure loss in pipe. This figure shows the relation between pressure loss by pumping test and pumping loss by calculation of friction resistance coefficient. The result shows high regression. Finally, conclusions. The conclusions of this study are as follows. It was possible to evaluate the friction resistance between concrete and inner surface of pipe by using the pumping evaluation system with friction resistance testing pipe. Next, yield stress and plastic viscosity of the fresh mortar showed a higher increase in case of higher concrete strength and tended to decrease overall after pumping. And estimation on the change in the rheological properties of concrete is needed in order to accurately predict the pressure loss in pipe during the concrete pumping in a vertical pipe and a horizontal pipe. Finally, in the pumping of the same concrete mix, the pressure loss with the increase of pumping speed tended to be bigger, and pressure loss in general tended to increase due to the increase in friction resistance with the increase of concrete strength under the same pumping speed. Thank you very much for your attention.
Okay, thank you for your information for our core technology for concrete pumping. Okay, any questions?
I have one question for you. If you back to your presentation for the inner friction formula, you have the inner friction formula. Yeah, if you back to that formula, please. FAR F over PRL.
Maybe you mean this
Yes,
part?
yes,
Yeah.
exactly. Does it related to the height from the surface? You know that you ran the test for the pipe, yes? And if you look at the inner friction resistance formula, does it related to the height or not? The height from surface to pipe.
Inner surface of the pipe.
Inner surface or outer surface?
No, inner,
Yes.
yeah. Does it related to the height? If you change the height, it will change or not?
이 서비스, 이너 서비스에 우리가 바꿔야 될 필요가 있는지 없는지.
Height of inner surface?
Inner friction 때문에 바닥에서 높이를 바꿔야 되죠.
Doesn't relate it to that. If we change, it doesn't. Okay. Thank you.
So, any more questions? Okay, thanks for your presentation. Thank you.